Today my topic is talking about performance and scale of Beyond Relational capabilities in SQL Server 2012. But before I actually go into that topic, let me give you a quick overview what actually Beyond Relational really means and what we are trying to achieve. So if I look at my favorite Beyond Relational application, I can use Outlook as an example. Why is that a Beyond Relational application? Well, it is managing both structured data, such as the header information inside my mail, as well as unstructured information, such as the context of my mail messages, the attachments, etc. And in addition, it provides a set of interesting capabilities over the data that I store inside my database, or in this case, inside my Outlook file, such as, for example, the ability to do structured and unstructured search, and have the ability to do related searches, like what I would consider to be semantic related searches. Although in the case of Outlook, it's very simply based on either messages that have the same sender or messages in the conversation. But you could imagine that they might find related documents based on some semantic analysis. So now if you build an application like that, unfortunately what you have to do is if you use a database to store the information, or if you use a file system to store the information, you basically always have to build these capabilities yourself to build it, to provide these services. So the goal basically is that we can provide you with certain services built into the data platform, so it makes it easier for you to build applications like these. So to kind of look at the pain points that you have, if you have applications that have relational and non-relational data, it's often hard. You have to build your own complex integration at the application tier. You have to duplicate functionality because they are not integrated. And if you, for example, have something like storing your files inside a file system and storing your structured data inside the database, you will have to compensate for unavailable services. Like, for example, you will have to build your own backup restore solution for the data that lives inside the file system that it somewhat integrates with the backup restore solution that you do for your data inside the database. So our goal is basically to reduce the cost of managing all this type of data by simplifying the development process, as well as giving you unified combined management and programming services for all the types of data inside the data platform, so you can make use of it when you're building your application. So what is the Beyond Relational mission that we have with SQL Server? Basically, the first thing is that we give you the ability to efficiently store all types of data, not just tables, but XML, spatial, documents, etc., etc. In addition, then, once we give you the storage, we also give you certain guarantees about the ability that we can process that type of data. And we give you these capabilities for all your applications that you want to build on top, such that we, for example, understand the data format natively. Like if you give us a spatial object, we actually know it's a spatial object, and we can do things that you expect us to do with a spatial object. The ability to give you a well-known API for putting files into the database, etc. And then finally, we give you rich capabilities and services over all that data, such as the ability to query over the data, to have search across the data, and have integrated manageability aspects, such as integrated backup restore for all types of data. So that's kind of what we are trying to do with Beyond Relational. Now, it's not a new story. The last non-Beyond Relational or truly core relational SQL Server instance or version was SQL Server 6.5. Then in SQL Server 7.0, we added search and unstructured data management. And then over the last couple of releases, we added a lot of capabilities such as, let me hide this here quickly, if that is possible. And we have the ability to basically now manage unstructured data, give you semi-structured data support, give you XQuery for managing XML, we give you spatial indices to manage spatial data, etc., etc. Now, in SQL Server 2012, we added a few new capabilities, and the ones that we are adding are, first, the ability now to actually manage your unstructured data not through a specific programmability layer like we had with SQL Server 2008 and Filestreams, where you had a specific API to access it, but in addition we also give you the ability to manage it directly, and we added a new kind of capability around semantic search that I will be quickly mentioning later in the presentation as well. So just to tie back, we have efficient storage for beyond relational data, we have the rich data programmability capabilities, and we have the services in form of the operations, in form of search, etc., over the data itself. Now, in SQL Server 2012, we are focusing primarily on kind of two or three things. One is that we are looking at rich unstructured data management, where we worked on scale-up for storage and search. We improved our access story to unstructured data from all applications, including applications that already exist, and give you rich insight into the unstructured data to make better decisions about what the data is about. And we also deliver more capabilities around building spatially aware applications, such as adding more 2D spatial capabilities, add spatial support in other components in the platform, and improve performance and scale as well. And last but not least, we also did some work on Service Broker, which is our messaging platform, by adding messaging broadcasting, which allows you to have a more performant way of distributing your messages to multiple recipients at the same time. Now, in this presentation, I'm not going to go into details about the functional aspects. For that, I have a list of links to presentation and webcasts at the end of this presentation. So you should be able to go and get some more insight into the details on each one of these points. What I'm going to focus in this presentation is primarily around performance aspects and scale aspects for these two topics around rich unstructured data and spatial support. So let's first look at rich unstructured data performance and scale. Our goal was that we can scale up storage and search to 100 million large to 500 million small documents at least. Now, this is not an upper bound. This is just what we basically made sure that we would hit. Now, with, of course, the understanding that if we are hitting that goal, given that we have enough hardware and can scale up more, we should be able to go up and further up to higher numbers than this without big problems.